Hello students, welcome to Distinction Learning Platform, and in this video we're talking about the periodic table. And before we begin our lesson here, make sure that you subscribe and don't forget to comment and like the video. Alright, and in the comment section there is a link that will take you to the website where you find other subjects like English, mathematics, biology, and other things. Okay, so let us begin now with the periodic table. What is the periodic table? The periodic table, basically, we know that it is the arrangement of elements according to their increasing atomic number. We understand about that. So let us write. What are we saying? We are saying the periodic table, basically, it is a chart that shows the arrangement of elements in order of increased atomic number, in order of increasing atomic number. This is a very basic definition. Now let us understand what we're talking about. Okay, since we are saying the periodic table is more, it looks like this. It's more like a chart that shows the arrangement of atoms. So I'm going to give a scenario here. If you look at this box, if I put element A and B, element A and B, the way they are going to be arranged, they are going to have different atomic numbers. Okay, so if you look at element A, if element A has atomic number of 2, then this one is going to have 3. As you can see, these atomic numbers are increasing on this chart. So that's what we call a periodic table. Again, what is a periodic table? A periodic table, basically, it is a chart that shows arrangement of elements in order of increasing atomic numbers. Now, if you look at atomic numbers, if I pick an element, let's say if I pick oxygen on the periodic table, remember that oxygen is going to have 8 and 16. If I say atomic number, what do I mean? I mean to say the number which is here below, which is 8. 8 is an atomic number. The other term that we use apart from atomic number, we also use what we call electron number. Now the number which is 16 here, this is what we call the mass number. So you need to know about that. Okay, so now the periodic table talks about the arrangement of these elements according to their increasing atomic number. Okay, so let us clear out this. Now, since we've understood about the definition, then what else are we supposed to know about this periodic table? So to go into details about the periodic table, these elements that we're talking about, they are going to be arranged in different categories. We've got the groups and we've got the periods. Okay, so what are we saying? This periodic table is going to be arranged in different categories. The first important thing that you need to understand is these elements are arranged in groups, and we're going to write also the period. Okay, two important categories. Now let's talk about the groups. Okay, so what are the groups? So the groups, we say these are what? Vertical columns. Okay, so the definition of groups, we are saying these are what? Vertical columns. Okay, vertical columns. So if you come here to this periodic table, which is here, if you we are talking about the groups we are talking about these vertical columns. As you can see, I'm coming from here then going downward. This column is the first group, then this is the second group, and that is the other groups, and like that. Okay, so what are the groups? The groups are the vertical columns. Okay, and these groups, they've got what different properties that we need to understand. Okay, we're going to talk about that. Now the question that you can ask yourself to say, how can I know that okay, a certain element is in group 1, is in group 2, is in group 3, or is in group 8? How do we know that? because if you look at the periodic table, the groups on the periodic table, they are about what? 80 groups. Okay, so what are we saying? So let us write that number. On the periodic table, we have 1 to 80 groups. Okay, now the question that I ask you to say, how do we know that this certain element is in a group 2, 3? How do we do that? Okay, so let us pick a certain element here. If I was to pick this one, which is, let's say, element x, okay, element x, then I give to say element x has maybe the atomic number of maybe 9. Okay, it has the atomic number of 9, as well as now it's going to have the mass number of 19, like that. Okay, then they ask you to say this group x element is in which group. Okay, this x element is in which group. So how do we know a known element the group number? Okay, so how are you going to do this? Is this one. So simply we're going to do what we call electronic configuration. Okay, so make sure that you know how to write the electronic configuration for you to know the group number. Okay, so the electronic configuration, we're going to use this number which is here. Okay, the atomic number. Always use the atomic number to write the electronic configuration of a certain element. All right, so now if you pick this 9, we're going to say, we know that in the first shell, we're going to have about what? 2 electrons, like that. Then in the second shell, we're going to put what? 80 electrons. Okay, now if you look at here, since I've removed 2 electrons from 9, what do you think, how many elements am I going to have? I'm going to have about what? Atoms. I'm going to have about 7, because we know that electrons, if you say 2 plus 7, we know that you are going to have what? 9. So that is the electronic configuration of what? Element x. Now, for you to know the group number of element x, simply you look at this last shell, the number on the what? Last part here. Okay, that's how you tell to say this element now is in group what? Is in group 7. Okay, so basically we're going to say element x is in what? Group 7. What is the main reason why we're saying element x is in group 7? We're saying it is because in this last shell, because this is where 2 is, this is the first shell. After the comma, this is the second shell. In the second shell, or this is the last shell, there are how many electrons that are there? There are about 7 electrons in the last shell. So that's why we're saying x is in group 7. Okay, so that's how we tell the group number. So we can write that one. We're saying for you to tell the group number, simply count the, so NO stands for number. Count the number of electrons in the last shell. A very, very important concept. Okay, that's how you find out the group number. Simply count the number of what? Electrons in the last shell. Okay, then the other important concept that you need to understand about the groups is the properties. So the general properties of the groups. Okay, so what are the general properties of the groups? So these groups, the general property is that these groups, they are going to have what? The same chemical properties. So the first important concept is saying to say the groups, as long as the elements, they are in the same group. Let's say like a certain element is in group 1, another element is in group 1. Basically those 2 elements, since they are in the same group, they are going to have the same chemical properties. Okay, so what we're simply saying is that these elements, they simply have the same chemical properties. Okay, and again, if you say chemical properties, what does it mean? Basically, if you start talking about the chemical properties, we are simply talking about how that element reacts with other elements. Okay, then that simply means that you are talking about chemical properties. Again, what do we mean if we say chemical properties? Well, we mean to say a certain element or atom reacting with other atoms or elements. Basically, those are the chemical properties of that same atom or element. Okay, so elements in the same group, they are going to have what? The same chemical properties. Okay, but the physical properties varies. Okay, so we can say similar or like it varying physical properties. Okay, but if you look at the physical properties, somehow they are going to be similar, but also they are going to vary, because if you talk about the boiling point of different elements in the same group, it's going to vary. Okay, what do I mean? If you look at the element A, and let's say this is element A and this is element B. As you can see, element A and element B, they are in the same what? In the same group. Okay? Because remember that the groups are what? Vertical columns. As you can see, A and B, they are in the same group, which is in the same vertical column. Now, if you talk about the physical properties of element A and B, they are going to be similar, but they are going to vary in some certain physical properties. Okay, no wonder I said varying physical properties. Reason being, if you talk about the boiling point of element A and the boiling point of element B, it's going to differ. This one maybe it can have 110 and this one maybe can have 150 degrees Celsius boiling point. So it differs. Okay, so those are the important points that you need to understand. Okay, another important chemical property. Here, they are going to have what? Same number of electrons in the last shell. Okay, that is the last property that you need to understand. If element A and B, they are in the same group, basically they are going to have the same number of electrons in the last shell. What is the last shell that I'm talking about, in case you are confused? If this is an atomic structure, okay, if that is an atomic structure and we have this arrangement of electrons like that, okay, so this atomic structure of the certain element, as you can see, this is the first shell and this is the last shell. All the elements in the same group, they are going to have the same number of what? Electrons. As you can see, this is the last shell, and the number of electrons in the last shell for this particular example, we're going to say 1, 2, 3, 4. So this one is going to have what? How many electrons in the last shell? 4. So which simply means that if I pick another element, it has to have what? Same number of electrons in the last shell. If this is the last shell now, it's going to have the same number. 1, 2, 3, 4. So if this is element A and this is element B, as you can see, for you to say this element A and this element B, they are in the same group, they need to have the same electrons in the last shell. Okay? Very important concept. So in summary, what we have talked about is, what is the groups? The groups on the periodic table, these are vertical columns, and they're about 1 to 8. So there's group 1, group 2, group 3, group 4, up to group 8. Okay, those are the groups number on the periodic table. And another important thing we said, okay, how do you identify that this element, this unknown element, is in this group? Then what do you do? First of all, you write the electronic configuration of that certain element or particular element or atom that you have been given, and you go on the last shell. On the last shell, there are how many electrons? There are about 7, and in the last shell, basically That's why you are going to use to determine the group number, and you're going to say this is in group 7 on this particular example. Okay, that's how you tell. And groups, they are going to have certain properties. They've got the same chemical properties, which simply means that they react similarly with other atoms. Okay, then if you look at the physical properties, they vary. I gave you a good example of a physical property, which is the boiling point. It's going to vary in the same group. Then what else? They are going to have the same number of electrons in the last shell, like I gave you in the previous example there. Okay, if you count the number of electrons in the last shell, they are going to have the same number of electrons. So that's about the groups. Okay, now let's go to another important concept. The periodic table also going to have the period. Okay, the period. The period, okay? The period now, what is this? Period, if this is a vertical column, now this you are going to say horizontal rows. Okay? Horizontal rows. So these are what we call period. If you come here on the periodic table, you come here and look at this periodic table. So this periodic table, if you're going now like this, you're going like this, you're going like this, these are what we call rows, horizontal rows. Horizontal rows now, we're calling them to say these are periods. And how many periods are on the periodic table? Because if you look at the groups, we say the groups are about 8. Then what about the period? The period, they are about 7. If we want, we can count. Going like this. 1, 2, 3, 4, 5, 6, and 7. So they're about 7 period. Okay. So on the periodic table, they're about 1 to 7 period. Okay. Now another important question: how do you know that this element is in a period 2, period 1, period 4? Okay, how do you know that? We come back again here, the same thing that we are doing to element X. Okay, this element X, we do not know the period number. Although now, since we know the group number by simply doing this, we're going to do the same thing. Okay, first of all, you pick the atomic number. Okay, then what are you going to do? You write the electronic configuration. Okay, let us practice. Let us repeat another one. Okay, if this is element A, then I say this is now, okay, this is 11, okay, and 23. So that is element A, which we don't know. Okay, so let us use whatever we learned from this previous example. The first thing that you need to do is what? Making sure that you write the electronic configuration. Remember, what is electronic configuration? It's just the ratio of arrangement of different electrons in different energy levels. Okay, so we write the first important thing, which is the electronic configuration of element A. So this element A is going to have the first, remember what I said, in the first shell we're going to have 2. Okay, then what do you do? Remember that these 2, you subtract it from 11, then you are going to remain with 9. Okay, then 9 we can get now in the second shell. We need to get maximum of electrons about 8. So I'm going to say in the next, from 9, since we've removed 2, then we've remained with 9. From 9 we can get 8. It's very, very possible. Then apart from that, now from 9, now since we've removed 8, what is remaining? 1. Okay, so that's the electronic configuration of that element, which is 281. If you want to be sure, you need to add 2 plus 8, which is 10, plus 1, which is 11. Now we are correct. We are not doing something which is wrong. Okay, since we are done with the electronic configuration, what else are we supposed to do? The next step is what? Now looking at the number of electrons. If you want to now look at the group number of this element, what do? You go on the last shell. This is the shell. Remember shells, how do you find the shells? After a comma, or before a comma, you say this is 1, then after a comma this is 2, and this is 3. 1, 2, 3, or simply you just count the numbers, and they are going to be equal to what? The energy levels. So this is 1, 2, 3. So there are 3 energy levels here. Okay. Now, if you want to look at the group number, what did I say? You go to the last shell here and you count the number of electrons that are there. Then you are going to say the group number for this will be now 1. So this element A is in group 1. Okay. Now we are concentrated on what? Finding the period number. Okay. So now what could be the period number for this one? Okay. The period number for this one, what do? You count the number of energy levels there, or the number of shells. So how many shells that are here? This is first shell, second shell, and third shell. There are how many? 3. 1, 2, 3. So how many shells that are here? 3. And the number of shells equals to the period number. So here the number of shells is 3. Then what about here? What will be the period here? The period will be what? The period number for this element X will be what? You count 1, 2. There are about what? 2 periods there. So that's how you find out the period number. Then you come here. How do you find the period number? You say you count. What do you count? Count number of shells. Okay, so we just simply count the number of shells and they are going to equate to the period number. Okay, make sure that you understand. Next, let's talk about now the properties. Let's talk about the properties. So what are the properties? Or basically the general properties. So like we talked about here, these they are going to have different. So here, since we said same chemical properties, but these they are going to have different chemical properties. Remember, if you say chemical properties of a certain atom, what did we say? It means that chemical properties, we just talk about the chemical reactions of that particular atom or element. So now these they are going to have different chemical properties. Okay, let's say if I pick if this is element A and this is element B. Element A and B, they are in the what? Same period, as you can see. If you go like this is the period. So A and B, they are in the same period. Okay. Although they are in the same period, but the way they react with other atoms differs. Okay, it's going to be different because they are in the what? Different group. Okay, so they are going to have different chemical properties. That's the important concept that you need to take note. What else? Then we go to this one. What about the physical properties? The physical properties, they always vary. Okay, these they've got what? Different again, or varying physical properties. Remember what I said about that? We said physical properties, things that are measurable, these are what we call physical properties. Like if you say boiling point, melting point, okay, and the weight of that object, basically we're talking about the physical properties. Now physical properties, they are always different. As long as that element is not the same element, it's going to have the different physical properties. Okay, so varying physical properties. What else? Okay, now we talk about here the same number of electrons in the last shell. Now what are we talking about here? We're going to say they're going to have these, as long as the two elements are in the same group, they're going to have same number of what? Same number of shells or energy levels. Shells or energy levels. Okay, energy levels, because the other term that we use apart from shells is energy levels. Okay, very important things. Now let's proceed. Okay, let's proceed. let's talk about more about this group. So we come back here. These were the general properties. Now if you go to the groups, so let's talk about the group 1, the group 2, group 7, and group 8. Their properties. Okay, so they are individual properties. So let's start here. So here now we're talking about the individual groups, so that now we fully understand what we're talking about. Okay, groups. So now we'll start with what? Group 1. Okay, we'll start with the group 1. Okay, so group 1. Okay, let me just do this. Group 1 elements. Okay, group 1 elements. So group 1 elements. So let's start with the properties. Okay. So group 1 elements, what is the other term that they use? So the other term for group 1 elements, we call them alkali metals. So group 1 elements are also called alkali metals. Why? Because group 1 element, if you try to react with a certain element, or maybe you try to react with water or with oxygen, they're going to form alkali, which is a certain base. An alkaline, it is a soluble base. So what we are simply saying is that if you get group 1 element, you try and react with other elements like oxygen, or maybe react with them with the water, they are going to produce an alkali, which is a soluble base. No wonder they are called alkali metals, because whenever they react, they produce an alkali, which is a soluble base. Okay, and if you look at this periodic table, this one, this is a group 1. So let us use red. So this one is the group 1. Okay, this is group 1 going like this. So going downward like that, this is the group 1 up to somewhere here. Okay, that is the group 1. Now, what is the other property? Okay, so group 1 elements, okay, group 1 elements, the other property is they are very, very what? Soft. Soft, and they can be easily cut by a knife. So soft, easily cut by a knife. By a knife. They are very, very soft. Okay, these are very, very soft. Okay, then the next important thing that you need to understand about the group 1 elements is that they are very reactive. So let's just say not very active. These are the most reactive metals, okay, on the periodic table. So if you look at the group 1 elements, these are the very, very most reactive elements on the periodic table. Okay, now if you talk about the reactivity series of the group 1 elements, here, how are they? So if I talk about the reactivity or most reactive metal, what do I mean? I mean to say the metal which if you look at their chemical reactions, it happens faster. Okay, it completes fast. Apart from that, they produce maybe fire, because if you look at the potassium, the way potassium reacts, is going to burn in water like that. But if you take potassium and compare it with lithium, lithium doesn't burn, doesn't produce like a flame. If you look at potassium, they react vigorous and explosively. So that's what I mean. If you say very active, because they produce something, okay, and their chemical reaction is very, very fast compared to other chemical reactions. Now, how do you know for group 1 elements, how do you know that this element is faster, is very reactive compared to this element in the same group? Okay, so in the same group, how do you know? So reactivity, so we're going to say, so this one is starts on the reactivity, so I'm going to use red here. So we're saying for you to know that this element is the most reactive than the other in group 1 element, what do you follow? We follow the trend. So as you are going down the group like this, and the reactivity series is going to what? Increase. How reactive the element or the metal is going to be what? Increase as you are going down the group. So reactivity increases as you go down the group. Let's just say down the group. Okay, so reactivity increases down the group. As you are going down the group, it's going to increase. Okay, so let us put something here. So if you look at this element is a hydrogen. Okay, hydrogen is in what? Group 1. Okay, but the reason why it is just placed alone here, but sometimes it's placed here. Okay, but I'm saying the reason why it is placed alone here, it is because this hydrogen atom sometimes behave like a metal. Okay, it can easily gain an atom like that, or easily lose an atom. So it has both properties of a metal and a non-metal sometimes. So it can do something like that. Okay, because it has one electron in its outermost shell. It is placed in group 1, but it can also act like a metal. It has that ability to lose what? An electron. Very important concept. Okay, this is hydrogen. Okay, and followed by what? This is the lithium, like that. Okay, all right, so now we go to group 2. So group 2, I'm just going to say a few things. Okay, so group 2. Group 2 elements. Okay, these are also called what? These are called alkali earth metal. Alkali earth metals. Okay, and the properties of group 2 element, they are more like similar to group 1. They are very soft and easy cut by a knife, but they are harder than group 1 elements. Okay, and that's the most important thing. But these are what we call alkali earth metal. Okay, and also if you look at the reactivity series for group 2 elements as well, it increases as you go down the group. It's just the same thing compared to what? Group 1. Okay, very important concept. Then you go to group 7. Okay, so group 7, these are also called what? These are also called halogens. Or the other term that they use are what we call salt formers. Okay, so group 7 elements are also called halogens or salt formers. Reason being because if you get a group 7 element and react it with a metal, they always produce a salt. That's why they are called salt formers. Okay, because they always produce a salt. Okay, and the other term that they use is what? Halogens. Okay, and the other important concept that you need to understand about group 7 elements are what? These are non-metals. Okay, they are non-metals, and mostly they are going to exist as the atomic molecules. Okay, the atomic molecules, what do I mean? If I get n element from group 7 here, so if you look at this periodic table, so we got group 1, group 2, group 3, group 4, group 5, group 6, group 7. So this, okay, this part. So those are group 7 elements. So if I pick one element on group 7, like let's say the common element is chlorine. So chlorine is going to exist as a diatomic molecule. Why? Because this is a gas. A gas always exists as what? A diatomic molecule, whereby you're going to put a 2 on chlorine here. Okay, so we can add on that important property. So we're going to say exists as what? Exists as diatomic molecules. Okay, Now, the last now is group 8. So group 8, I'm going to write it here. Group 8, which is this one now. Okay, so group 8. These are what we call noble gases. Okay, noble gases or inert gases. The reason being they are called noble gases or inert gases because they are unreactive. If you get a group 8 element, like you get a neon, okay, you get neon, then that one, it can't react with any other atom because they are unreactive, they don't react, okay. So that's why they are called inert gases or noble gases, okay. So that's about the groups on the periodic table. And another important group that I didn't talk about is this block. As you can see, this block, okay. This block starting from here between group 2 and group 3, this block is called the transition block, or it's a group of transition metals, okay. That block between the group 2 element and the group 3 element is a block of metals that are what? That are called transition elements or transition metals, okay. The good example on this transition metal that I can add is copper. Copper is a transition metal. There's a reason why they are called transition metals, because just from the word transit, to transit is to change. So they change, okay. They change what? They change their valence numbers, okay. If you look at copper, copper exists as the 2 elements. So we are going to have copper 1 and copper 2. As you can see, there are two different elements. There are two different atoms here. So we are talking about the copper 1 and copper 2. Copper 1 is going to have the valence number of 1, and copper 2, they are going to have the valence number of 2. As you can see, the valence numbers are changing. No wonder we are calling them transition metals. And the other important concept about the transition metals is that apart from changing their valence numbers, they also produce colored products. Okay, if they react with a certain element, they are going to produce a colored product. Very important concept. Okay, then what else? The last important part is this one. As you can see, there is this block that I've written here, this part. These are fun elements, these ones, okay, starting from here. So this one, 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 and like that. So these elements, just after and before that line, these are what we call metalloids, okay. So these are called metalloids. Let us write this. So these are called what? Metalloids. Why are they called metalloids? Because they act like a metal and at the same time they act like a non-metal. What do I mean by that? So these, if you take any element from this block, at some point they are going to be acting like a metal, okay? Then at some point again they will start acting like a what? A non-metal. Remember that from the basic concept of a metal, if they are reacting with other elements, they always release a certain electrons, or they lose a certain electrons. And these metalloids, they can also do the same thing. They can also lose a certain electron. Now, if you go to the concept of non-metals, they like gaining electrons for them to be stable. Again, that concept, for metalloid, it is possible. They also at the same time, they like gaining electrons. No wonder they behave like a metal. Again, they behave like a non-metal. And this is where we end from. And make sure that you study more. Until next time.